welcome to React London. It's good to see so many people could make it today, given the dreadful weather. I think it's safe to say that summer has well and truly ended. So my name's Rain, and I'm a software engineer at Red Badger. I'll also be the host for you today. So for those of you who don't know, Red Badger is a digital consultancy, and we work really, really closely with some great clients to provide some awesome user-centered products. We also host a variety of events, including this one. If you are interested in finding out a little bit more about what we do and the events that we host, feel free to go to our website at red-badger.com. Please help yourself to any drinks at the back. And if you are 1 or 2, maybe 3 drinks in already, you'll be happy to know that the toilets are just straight out the way you came on the left. There's also toilets at the back just here if you can't wait and you need to go mid-talk. We have some great talks for you today. So we're going to kick things off with Craig, who's from ASOS. And he's going to talk about lazy loading. We're then going to have a little talk from Thomas from Theodo, who's going to let us know a little bit more about graphing libraries in React. And then finally, we're going to have a chat to Daniel from Red Badger, so he's one of our own, and he's going to talk to us about state management. So we're going to do the first talks back to back. Each talk will be about 15-20 minutes, and we'll have a little section for you guys to ask questions if you want to. If you just want to raise your hand at that time, if you want to ask a question, someone from the back will come ahead and come and give you a mic, and you can ask your question. Be sure to use our hashtag, ReactLondon, all one word, to let us know how you're finding the event, if you do want to do any sort of social media posts or anything like that. Cool? So, without further ado, let me introduce our first talker for today. Please welcome Craig.
Is that okay? Can you hear me okay, guys? Amazing, brilliant. So welcome to ASOS, guys. It's great to have you here in our new space and see so many faces ready to do some reacting. So today we're going to talk about lazy loading. But to start, my name is Craig and I work in the ASOS web team, and specifically my team looks after the product listing page and the saved lists page. So today we're going to go through a journey on how we can use lazy loading to dramatically improve performance. So for each technique, I'm going to show you very, very briefly a little bit of code. Unfortunately, 20 minutes is just not long enough to do a deep dive code as much as I'd like to. And then for each of those, we're also going to do a quick demo looking at the dev tools just to see how those techniques are applied. Cool. So I want you guys to imagine that you are starting out a new project or product, and it's maybe an e-commerce site or a blog, anything which has a lot of articles or products going down the page. So you might have, say, a title, an item count, and then maybe a component that loops over all your items, all your articles, and displays them on the page. So to that effect, you might have something which looks a little bit like this. So some sort of title, maybe a subheader that displays your item count, and if you have items, a product tiles, in which all we're doing is mapping over all the items on our list and displaying them on the page. And that would look something like this. So any Love Island fans here? Oh, very quiet, very quiet. So a nice simple product listing page. Now, if I use the Chrome developer tools, we can profile this application, and I reduce the network speed down to a fast 3G network. You can see at the top there. Just to sort of resemble a classic mobile network connection speed. So none of this enterprise sort of Ethernet wire. We're talking like commute home territory. And for 200 items on a page, it took a minute to fire the onload event. That is eye-wateringly slow. A minute for your page to fully load. So we sometimes use a thing called Lighthouse here as a performance reporting tool. So some of you might be familiar. And it can give you some good metrics to analyze the performance. And what you can see is our score isn't very high here for this application at the moment. I've not done very well on my first attempt. What is noticeable is the first CPU idle time, 7.6 seconds. And this being so high is generally a common symptom of trying to load too many images on page load at a time. So the question is, what can we do to improve this performance? Well, recently, and I say very recently, Chrome 76, the team added a new attribute which you can append to images and iframes of loading. And in effect, what this allows you to do is just defer the loading of images until they enter the viewport, or near enough. And I highly recommend you add this to any and every image on your applications, because it is a really free, quick win in terms of performance. So let's just add it to our app. So I've got my product tile here. Within my tile, I've got a little link, an image, a text, a price. I'm just going to drop into the image here. And in order to use this lazy loading with Chrome, all you need to do is add one prop with a property of lazy, and that's you done. So if we head over and refresh, instead of loading 105 images, I've got about 40 there. And if I was to just scroll down the page, what you should see is we're just lazy loading about 2 images at a time. So I've reduced that down from 105 images on page load down to about 40, and I'm just progressively, and it's, it's pretty seamless. I don't think I can find an image that hasn't loaded by the time I got to it. And with that, we get down to 11.7 seconds on a fast 3G. So that's 5 times faster than we were. So that's a huge improvement. Again, if we look at Lighthouse, the most notable change is now that CPU idle time. In effect, our application is now likely to respond quicker, and it's less likely to lock up due to blocking the processing. So future processing, maybe future API calls, are likely to happen more reactive and quicker. They're not going to be blocked by our image loading. But this is just for Chrome. At ASOS, we are a mobile-first, multi-platform company, so it's just not good enough to only be doing this for Chrome. We want a consistent cross-browser experience for all our customers. Now, the Google team, what they do is recommend the feature detect for this attribute, and then polyfill if it's not there, i.e. you're not on Chrome. And their recommendation is to use a third-party library called Lazy Sizes, and this will just handle the lazy loading of images for you. So let's just have a look at how that works in our application. Now, I've cheated here a little bit. I'm just going to do a Blue Peter style, just uncomment something and dig in there. So to use lazy sizes, for instance, all you need to do is import the module. I've also imported this plugin that allows you to fall back to the native capability of Chrome. And in terms of using, all you have to do is, again, if you're on Chrome, provide loading lazy, and it will use the native lazy loading capability. Or otherwise, any image that has the class appended of lazy load will then be lazy loaded, provided you pass props of data source and data source set. And what will happen is, as this image enters the viewport, those source and source set data sets will be then mapped to the respective source and source set, effectively loading your image. So how does that look in our application? So again, you can see 40 elements there in Chrome, and it's doing its native lazy loading. But as I say, we're big on iOS Safari, for instance, at ASOS. What have we got here? So you can see here we've got around 8 images loaded. And again, this third-party library is doing a 2x2 lazy load of our images as we scroll down the page. Now, some of you might have noticed this. Is this the best React fit? What I've done is imported a third-party module that is behind the scenes mutating a component or props of a component which should be otherwise controlled by React and React DOM. And this is a bit of an anti-pattern. So, and excuse the pun, my recommendation would be to actually go fully controlled and hook in an intersection observer. Now, for you that don't know what an intersection observer is, it's a relatively modern API, and it's essentially an API that allows you to observe intersections, i.e. when any element intersects with any other, i.e. the viewport, it will fire an event. And this is quite useful. And the important point to make with an intersection observer, unlike scroll event listeners, etc., all the calculation and event handling is handled off of the main thread. So this makes it highly performant. So what we're going to do is try out another node module. It's a lot easier if it's already been done. That uses an intersection observer in this style. So again, I'm just going to swap out into this LazyLoadObserver. And what I've done is pulled in this React intersection observer. Now I'm going to use the hook form. It does also provide an HOC if you're still using sort of traditional class-based or component will mount like components. And what this hook allows you to do is provide a little bit of initial config. So I've said only trigger once. So once I've lazy loaded an image, that's fine. Don't get rid of it. Don't worry about doing it again. And also a root margin. So this is part of the intersection observer API. It allows you to provide a little bit of a buffer. And what I've said with 100% is when I am a viewport away from the viewport, there's a lot of viewports in that sentence, I want you to lazy load my image then. What it then gives you is a ref, which you can attach to the image you want to lazy load, and a boolean for whether or not that image is in view. And then all you need to do is attach that ref to your image, and I've got a little bit of logic to essentially say, for the source and the source set, when I'm in view, load up my source and my source set, effectively load my image. So again, how does this look in our app? So this time, what you can see is I've got about 8 to 12 images there maybe, and that's sort of double the viewport. And just as I scroll down, those images are just lazy loading again. And this is cross-browser as well. And in this way, it's controlled through React. So I'd highly recommend checking out this package. So just to recap, at ASOS we have a multi-layered approach to lazy loading. We aim to utilize native APIs where possible. Where not, we provide a consistent cross-browser experience for our users through polyfills and other methods. And lastly, in addition to lazy loading of images, we also want to lazy load API data, which we'll now look at in more detail. So a couple of months ago, we finished the replatforming of our save list application. This is an app or part of the site that allows users to save their items for later. Now, as well as lazy loading of our images, we also wanted to lazy load the product API data just to speed up the initial load of the site. Now, another thing that we have to consider, and I maybe should have mentioned this earlier, is that the Intersection Observer API, though very powerful and mostly supported, is not quite there in browsers such as like Internet Explorer, of course. To which end it falls back to scroll event handlers. So what we wanted to do was minimize the number of observed elements whilst doing any kind of lazy loading of the API, just to minimize the number of scroll event listeners. So our solution was to come up with this LazyLoadObserver component. This is a component that stretches the full length of our product tiles, and it contains blocks that represent continuous sets of loaded and unloaded data, or items even. Now, the idea was to only observe blocks that represent, so these red ones, sets of unloaded items, and upon intersection with the viewport, or just below the viewport, fetch product data from the API in a relatively lazy way. So what would this look like in our application? So if I come across and I just come out of my product image now, and I go into my product tiles component, index, I'm going to do the same again, and just uncomment this one. I've also got a reminder here to just change my batch size. So what I've been doing before is going and trying to fetch 200 items at a time. I'm now going to bring this down to about 12. So instead of fetching all my data, I'm going to just look to pull down 12 items at a time. Now, to mirror that image we had before and hopefully make this a little bit clearer, again, I've got a green block, which is part of my LazyLoadObserver, that is covering all of the loaded items, and a red one covering all of the unloaded data. And what this component is going to do is, as that red one enters the viewport, or just below, based on my buffer, it's just going to fetch the next batch of API data in a lazy fashion. So just to demonstrate this happening, if I go into, so there's my LazyLoadObserver, I then have an observed block. I'm just going to uncomment this dispatch that is actually going to make the API fetch. And then coming back, and I'm going to go to XHR and just limit it to our API data. What you should notice is as we scroll down the page, we're just lazy loading that API data as we go progressively. I'm scrolling relatively fast, and it just picks it up, pulls it down, until eventually we have all the data, at which point the lazy load observer unmounts itself. There's only one block. It represents all loaded data, thus I tell it to unmount. And that was relatively performant, at least demo in front of you guys. So to compare this versus just the image lazy loading, what we see is a large performance gain in the CPU idle time and time to interactivity. Effectively, loading and just processing fewer products up front makes our application load faster by about 1 to 2 seconds. So that's really good. Now, some of the eagle-eyed of you might have noticed that I've actually been running all this on a React development server using Create React App. And I've been a little bit cheeky, and all these performance reports you've been seeing, they're quite low scores, have also been for that development server. So I've been doing myself an injustice. But the reason I've been doing that is just it really highlights some of the performance differences when we're on a development server. So just to give you an anecdote, a 20% performance increase on, say, a slow development build that takes like 5 seconds to load will be about a second. That's quite noticeable, versus a production one that takes maybe 2 seconds. It'd be, 0.4, less than half a second, might be within the variance of performance runs that you see anyway. So it just makes it slightly easier to highlight those 1 to 2 second differences that we've been seeing. But if I now run that on a production build, you can see that we're doing not too bad. We're with image and API lazy loading down to sort of in the region of 2 to 4 seconds for our application for sort of 100 to 200 items. Now, the question is obviously, what can we do to improve this further? So up until now, we've been focusing a lot about how and when we load content, but we also should be considering how much content we're displaying on the page. And to this end, what I want to look at next is our usage of the DOM. So the Google team have a recommendation, and it's fairly simple. Don't put too many things on your page. Don't nest things too deeply on your page. And that's quite an easy thing to do in React. As you're building out your components, maybe you have a wrapper div, and then it does a component inside, and you have another wrapper div. This is a huge suggestion to really reach for things like fragments, or just really sort of check, do you need those components on your page? And the last one is actually quite important for something we're trying to do here. It is saying that you should have no more than 60 child elements to a parent. Essentially, if you have a list, you shouldn't have more than 60. And just to give you an anecdote, on our women's jeans category, we have over 1,000 jeans. What happens if I want to show all of those jeans to my customers in one list? Well, 1,000 jeans, 1,000 product tiles, that's going to put me in the realm of about 10,000 nodes on the page. So that's well above the first one. And 1,000 is clearly bigger than 60. So how do we get around this problem without breaking these guidelines and stay performant? So one of the best ways to do this is to use a Sentinel-like approach. So this approach is to only render a small number of your items as a sliding window and place what are known as sentinels above and below your list. Now, as either of these sentinels enter the viewport, either from the top or the bottom, as you're scrolling up and down, we shift the items by an offset, and then either decrease or increase the heights or paddings of the sentinels above and below. And this just gives the impression of scrolling through the page. Now, that's quite wordy and probably quite hard to sort of conceptualize, at least I find it so. So let's put my application on the diet and we'll just demonstrate what I mean by this. So if we go back to the product tiles again, and I'm going to comment this one. And what I'm going to do for this demo is actually, I'm going to get rid of the lazy loading of API data just to prove how powerful this technique can be. I'm just going to move on to the Elements tab now, just to demonstrate. And what I want you to notice is for 105 items, we've now only got about 12 tiles on the screen. Above and below, we also have these sentinels. One above, height 0, one below, about 16,000. And if you notice, now this is where, if you can see that scroll bar just from the top right there of the screen, I don't know if it's very visible, you should notice it's quite small. We've effectively got a page height that represents the full page. So for accessibility purposes, I know exactly where I'm on my page. That's great. Now, as I scroll down, I want you to just watch the number of tiles and the heights above and below of these sentinels. They're changing, but the number of tiles aren't. In effect, by just shifting up through the tiles as we scroll down and increasing and decreasing these sentinel heights, and every time a sentinel comes in, observing it, loading the next set, pushing it down, changing the heights, we can minimize the DOM elements for a list of essentially arbitrary length down to 12 or fewer, depending on the viewport. So what does this mean? Lightweight is fast, effectively. So, and I'm not even lazy loading product data anymore. So I want you to notice the drop in first contentful paint, the first CPU idle, the time to interactive. You know, we gained about a second there by reducing down to this. And you get further gains if you did lazy loading of API data. Now, I think the obvious question before we end this is, can I get that number to 100? There are a hell of a lot of things I'm not going to cover today, which I'd love to. And maybe another talk, maybe we come back here and we have another meetup, that would be grand. You know, I could be looking at PWA and AMP, I could be doing React Lazy and Suspense, maybe critical render path territory. Maybe I should load the first part server side and send it down. That would make it slightly quicker. But beyond all of these, I am very much an advocate of what is the simplest thing to do that will reap the greatest benefits. And in this case, it feels like cheating a little bit. It was just compression, specifically Brotli compression. So if I applied that to my production server, I can now get us down to about 1 to 2 seconds, under 2 seconds easily. And this is for that technique without lazy loading of API data for loading of a list that could be arbitrarily large. Not infinite, but it could be 2,000 products, for instance. Now, if you want to see that technique in the world for an infinite list, I'd recommend checking out the likes of Instagram, for instance. I'd recommend go home, have a look, and you can see this in the world. People are using it. It's very performant. It's very good. Now, I've spoken to you a lot about what you should be doing, but I haven't spoken to you necessarily why. And there's the obvious one, performance, faster page, happier customer. But there's also benefits known for SEO, faster page ranks higher. And lastly, there's also a link, statistically proven, between performance and conversion rate. So if you were just to take Walmart's anecdote there, if we were, say, to be a company that made, I've written this down so I don't get it wrong, about 10 million a year, then just by increasing 1 second, we could raise our baseline by 200,000. I've got it written down, I got it wrong. £200,000 a year. So there are some huge gains to be had. So if you think about your e-commerce site, you think about your blog, your conversion rate, it might not necessarily mean money. It might just be hits and likes and all this kind of jazz. You could raise whatever that is by 2% just by being a second quicker. Thanks everyone for listening. Please welcome any questions.
Thank you very much, Craig, for that great talk. Do we have any questions? If you do have a question, just raise your hand and we'll get a mic to you. Come on, surely there's one.
Stunned into silence. Got one here.
One here? I'll give you my mic.
Thanks for the talk. So you've given us a couple of statistics for performance gains, but my understanding is that they are all for Chrome, right? And my experience is that the worst performance that you can get is in things like Internet Explorer.
Yeah.
Out of the top of your head, and this is an unfair question, but do you happen to know how much the experience was improved for Internet Explorer users?
So, unfortunately, I don't have any metrics to hand, and we have a saying here at ASOS, which is know your numbers, and I failed on this aspect completely. But what I can tell you is that we applied that second technique, the LazyLoadObserver, to our save lists, and it is relatively smooth. I know it's using that scroll handler fallback. It's not much of an answer. If you really want, I can duck out, get you the metrics, and I can come back in sort of afterwards, and we can have a little chat. How's that?
Yes, please.
Yeah, okay. Amazing. I'm sorry everyone, that's a useless answer.
No, thank you.
Any other questions?
Hi there, thanks for the talk. Are there any libraries out there, particularly I'm thinking of the Sentinel technique, that's really interesting. Are there any libraries that kind of encapsulate that functionality?
So as a starter, I would check out ResearchGate's, I believe it's called Infinite Scroll, something like that. So if you search the keywords of React, Infinite Scroll, Intersection Observer, you'll probably find it, or you just go on ResearchGate's GitHub, you'll probably find it there. They have a really good example of something very, very similar, except they implement what's known as a false floor. So what I did was have a bottom sentinel there, which expanded height, which gave me a set fixed height of the page. What a false floor is you have the top sentinel, and as you scroll down, we just append stuff to the bottom, so the page height grows as you get down.
Right.
So I'd check that out, though I'd be wary of that one just because false floors are generally not very accessible.
Yeah.
As you hit the bottom, if you're loading in more content, and for say you ever have a footer at the bottom of the page, anyone who's a keyboard user or even a scroll user will never be able to get to that because it'll keep loading in stuff in between. So check out that. I don't know of any other examples other than the React Intersection Observer one, which gives you a useful sort of set of hooks. You can apply that to your above and below sentinels. Otherwise, it's just a little bit of maths. I'm happy to talk through after if you're interested.
Brilliant. Thanks very much.
Cool. So if you could put hands together for Craig.
Thank you.
Brilliant. So before I introduce our next speaker, I'm sure some of you have noticed the lack of pizza that we're currently facing. To those people, I just want to say, rest assured, you will get your pizza fix. There are some more on the way. Should be here for the break after our next talk. Cool? Sweet. So if you'd help me introduce our second speaker, please welcome Thomas.
Okay, so welcome guys to my presentation. What I'd like to talk to you today about is two things, really. First thing is how generally you can make decisions about NPM libraries. And two is how I chose the number one React graphing library for my project. So just to kick off a bit, to give you a bit of background, I'm currently a full stack web developer at Fiodo. We're a small web development agency based in Soho, and we're currently open to recruitment. So if you're a full stack dev who likes to work in React, Django, Node.js, feel free to apply on our website. Cool. So first of all, I'd like to ask you guys the question of why do you think it's important to choose the right library? Any hands up? No. Yeah, that's right. No, just go ahead. Hand up. Yeah, for sure. So there's a bunch of different reasons, which we'll dig into later in the talk. The one that I find the most important for me is saving time and also building client trust. So let me give you a bit of a story. So I was on a project a few months ago where basically we were actually taken over from another agency. It was a bit of a sad situation for the previous agency because after a bit of a 3-week trial period, the client ended up saying, oh, this is actually, you guys aren't that great, let's switch to someone else. And the reason for this was because they had a really good start, so the first week went really great. And then second week in, they actually realized that the graphing library they're using is not the right one. So they had to go back, change all the graphs on all the pages, and really ended up dropping the ball. And the client was kind of like, well, what the hell, guys? And they ended up losing a lot of trust, and eventually the client said no to further development. So that's kind of what I want to help with you guys today. So let me start off by giving you a few examples of the kind of choices that you might have to make throughout your project. So one typical one that you might find is, what kind of UI library might you use? So are you going to be using your own custom components, or are you going to be using Material UI, Blueprint? Those two are quite popular. Or maybe Bootstrap, or Grommet, or AndDesign, or there's countless other choices. Another quite common one is React Table or React Virtualized. Which one is better? And kind of final choice, the simplest one of them all is, what's the best graphing library? So this is a fairly straightforward decision, as you've probably experienced before. There's not really that many libraries. Really not that many libraries to choose from. Okay. So first of all, I want to start with talking about some of the principles even before you come to making the decision. Like, what are some of the things that you should think about? So first one is kind of like, okay, is this feature going to have a big impact or a small impact? Like, if you sort of look ahead in your project, how many pages are going to be using, say, a table? You might find that the majority of the project does have a table embedded into it, whereas you might only have one page for like a dashboard where you might use graphs. So in that case, you don't really have to think about too much on pondering what the best library is for that. When it comes to a big decision, I imagine a lot of you guys probably have a common thing to do, which is Google. And when you do Google what is the best library for X, you may come across generally 4 kinds of sources. So you might find some kind of article, perhaps on Medium. You may come across a Stack Overflow post, or maybe GitHub issues, or even better, like a Reddit discussion where people are really discussing and sharing different angles of their experiences. And also, you might just ask your colleagues as well, if maybe you don't find something useful. One thing that I'd recommend here as well is, if you do end up coming across a situation where you're branching into like a new territory and you've got maybe a day to spare, you can always post on Reddit yourself, asking a particular question, asking for recommendations. So let's try looking for a library. Okay, so let's say I want to find out what's better, React Table or React Virtualized. So I might type in this. As you end up sort of scrolling through the pages, you kind of find this one is at the top of the list, and it actually gives you like a really nice summary of the advantages and disadvantages to each, and specifically tells you the use case of where you might use React Window versus where you might use React Virtualized. So this is kind of solved, and you're all good to go. Now let's try the same thing with graphs. So let's say, because there's quite a few libraries, I type in best graphing library React. So as you scroll down the list, you may notice that a lot of the pages are like best 5 libraries, top 10 libraries, amazing 20 libraries to use for visualization of graphs. And the kind of problem once you start reading through these articles is that they kind of give you a good set of libraries to choose from, but sometimes too much choice. It becomes hard to narrow down which one is the best for you. So that's what I want to help you with. So there's kind of 2 ways of approaching this problem, where you come across a big decision and you're unable to make out what the best answer is. One is having some simple metrics to in your mind that you can use to quickly find out details about two libraries. And two is kind of doing a more thorough investigation if you have more time. And this also, the metrics part also kind of helps you with the small decisions that you have to make day to day. So it's going to be great to talk you through them. And before I get started in showing you sort of the example metrics that you might use, I just thought I'd mention that before you go into trying to make this decision, kind of try and think about what is actually almost like the success criteria of your choice. Like, what particularly are you looking for? Are you looking for speed, performance, maybe long-term support, or maybe just good developer experience? And so let's start off with some useful indicators. So the first one that you might look at is, actually one thing beforehand. So with this particular context, as I showed you, there's quite a lot of different graphing libraries. So the way that I even managed to choose between them was first reducing the huge set of 100 down to 6. And I did that because I had some additional time and I knew I was wanted to choose the best one. I basically went through the top 6 articles I found on best React graphs, and then just saw which ones were the most mentioned and then took the top 6 of those, essentially. And so that allowed me to take a much deeper comparison on the next 6. And just to let you guys know, those were React Viz, Victory, Recharts, VX, Nevo, and Chart.js. So as I said, probably one of the most common metrics that you might look at is the number of NPM downloads. So this is really nice because when you have a lot of downloads of a library, it means a lot of people are using it, and there's likely to be a lot of discussion around particular issues. If you come across a bug, it's likely that someone has already solved it for you and you can find the solution online. And so the tool that I like to use for this is basically NPM trends. So this allows you to kind of type in the libraries that you want to compare and see how many downloads they got over a longer period of time. As you can see, Recharts is the best performing in this area, with the next one down, React Chart.js 2, has only half the amount of downloads. But the one disadvantage of this is that obviously when you have a library that gets ahead, it's likely to get more and more ahead as more people spawn discussions about this. So as you can see, because Recharts was quite popular in the beginning, it kind of continued to just steam through the other libraries. So even though those libraries might be good and might have had a lot of development time in between, they might not get to see the light of day. So that's why I kind of like to look at other metrics as well. Another good metrics, quite a simple one, is just looking at the number of stars of the GitHub page. So you can find this in just in the top right corner of when you go to the GitHub page. And this kind of tells you whether people actually like using the library. And if you take this a step further and do sort of the number of, kind of normalize the ratings, so essentially number of ratings divided by the number of downloads, you kind of, number of stars divided by the number of downloads, you get a rating metric where even though a library might have been downloaded a lot of different times, you might have one library which has been downloaded a huge ton, there's actually not that many people have started. So one good example is, say, take a look at Victory that has 50,000 downloads almost, but only 6% rating, whereas VX, which has just like 10,000 less, has a 26% rating, so almost 5 times the amount. So you can see from here that VX and Nevo are really strong in this regard. So it is likely that you might probably have some kind of typing on your project. So two tools that I like to use is a website called TypeSearch, which basically allows you to find if a library has native TypeScript support, which can be really time-saving when you're and smooth the integration process with the rest of your project. So for example, I can search React Viz and notice that it doesn't have native typing support, but I can search Victory and see that it does. And in the case where you don't have typing support, it's not the end of the world, because you can go to this library called Definitely Typed. I'm not sure if you guys have heard of this before. Can we have a raise of hands if you've heard it? Nice, okay. So basically this is like a community pooled resource of TypeScript definitions that haven't been officially integrated into library, but people have submitted for their favorite libraries. And you can see that there's actually quite a few on here, and it's quite a popular resource. So if I just look at the types folder here, there's over 5,000 entries, 5,000 different libraries. So maintenance, I think this one is a really big one. So another story on this one is our neighboring company called Sakara. They did some research into what the best JavaScript libraries as opposed to just React, and they asked data visualization CTO, what is the #1 thing that you look for in a library? And they said maintenance, like the activity on GitHub. And the 3 reasons why this is kind of important is, one is obviously a well-maintained library is likely to have less bugs as people start merging pull requests and continuously reacting to feedback. 2, it's going to be up to date on new code standards. So for example, with Material UI, when React hooks came out, all their examples pretty much straight away migrated to use React hooks, which is really cool. And then the third thing is new features. So basically, if you're specifically looking at graphs, over time, if a library has enough traction and a lot of activity from the owners, you probably end up seeing that they actually start adding and diversifying the library even more, adding more graph types. So it's something to look forward to. And the way that I like to measure this is if you, again, go to the GitHub page of, say, React Viz, you can take a look at the Insights tab on the far right here, specifically the contributors option. And you can kind of see just over time the number of commits, essentially. And also another useful thing is you see how much different people have contributed. So you can see if it's really just one person contributing the most of it, or if it's much more distributed. And so I've just gone ahead and compiled the statistics for all 6 of the libraries that I mentioned. And this is kind of what you get. From this, you can kind of tell that Victory is really good in this regard, along with React Viz and Recharts, whereas the other ones, not so much. So Chart.js, this is because it's a wrapper around the Chart.js library, which is pure JavaScript. And Nevo and VX, this is because they actually have only one owner, just one guy sort of really enthusiastic about graphs, I guess. And another thing as well, which is pretty useful, is if you go to the Issues tab. So the kind of ratio of open to closed issues kind of lets you know how active the owner is in trying to merge these pull requests and fix bugs. And a library like React Viz, you can see that the ratio is a lot lower compared to something like VX, where there's only 48 issues over 250 in total. And so this is kind of what this metric kind of shows you. And the SPOF, so that's just a little fun statistic that I compiled. It's basically like the single point of failure. If in any unfortunate circumstances where someone may get hit by a small bus, if the library is going to have continued support, basically it's just the number of commits of the top user compared to the other contributors. So React Viz is really good in this regard. So one thing, if you're looking for fast performance, I think something to watch out for is size and dependencies. So although this is not really that important if you're developing, say, like an internal tool, If you're developing something that's going to work on mobile and you want a good developer experience, good user experience, you don't want them, like the size of a library can, especially something like graphs where there's a lot of content, maybe a lot of animations, it can make quite a big difference to the loading speed. So one tool that I like to use is called bundlephobia. If you just type in the name of the library in the top, it comes up, tells you the minified size and the minified plus gzipped, as well as actually how much time it would take to download this on, say, 3G. Okay, and as well, the lower the number of dependencies, you probably have a slightly better security. You probably have slightly better security because the less kind of dependencies, the less libraries that the library depends on, the less likely there might be a vulnerability which you'll have to go and update in a project where you're just shipping, like, say, once. And this is specifically, again, the statistics for all 6. So you can see that VX is actually doing a lot better, even half, like more than half, the, say, recharts, which is like the compressed size, which is 120 kilobytes compared to 52. So really could cut down a lot of time, and that's actually because of the reason that they decided to modularize the library. So instead of including all of the graphs in one package, they actually split up the library into multiple packages, so you only have to import what you need. And that's the same case for Nevo as well. One thing that's kind of really overlooked for, which I'd just like to give a shout out for, is documentation. So if you're trying to develop some kind of feature really quickly, it's quite specific. You're looking for specific props, very small piece of functionality. I think search is really useful when it comes to documentation, like having, if I show you Victory, for example, inside here I can say search for animation or color, and it instantly shows me all the things that are related, and particularly to which graphs as well. Another useful thing is the responsiveness of the docs. So if you don't have something like JS Fiddle or CodePen examples, having something like Victory where you can actually edit the examples inside the page itself. So say, for example, I can change this to be a blue color, is really cool for quickly testing things out. So the combination of searching things up quickly, typing in the props here, maybe changing this to something like area. Oh, sorry. It's this one, area, or maybe line. It's a really quick development time. And also Storybook is quite nice if you're looking for specific visual examples. Another shout out for the good documentation is Nevo. So one thing that I found really cool with them is the fact that they actually make this prop side very user-friendly. So you can actually sort of scroll through these, and they have nice sliders which you can interact with, toggle some options on and off, fiddle around with this. It's really quite pretty. And why this might be useful, so if you have a particular product owner or project manager who's really specific about the details, and maybe don't want to get involved with the actual code itself, you can sort of give them this and they can tweak the graphs for themselves to find out what's best. And also useful if you don't have a designer as well. So on the next part, in terms of the thorough comparison, if you weren't able to find, like, if you're developing a lot of features, you may find it useful to see, okay, what's the functionality of the library versus the features that I'm going to develop? Do they match up? And since I want to dive deep on the graphs, I did this for you and kind of showed you that I kind of bucketed the different graph types into 4 different categories for each of the library. So the categories were basic graphs, scientific graphs, financial graphs, and statistical graphs. The best performing library in this regard was React Viz, which kind of meant that it was most flexible to do what we wanted. And I also kind of compiled a little cool metric, went around the office, asked, how would you rate the libraries, which one is the best looking? If you had to develop a prototype with no designer, which one would you choose? And people really liked Nevo and Recharts. Whereas React-Viz and Victory people didn't really like, and VX was quite opinionated. So yeah, so my summary on graphs. What is the best graphing library? Well, it depends. So there's a few. I think the important thing is what is your use case, and what is the best library for that use case. So I have a few use cases which might relate to some of you. One is if you're developing a long-term project, like it's going to be going on maybe for a few years. Two things that you want to watch out for is how much community support does it have, and what does the maintenance of the library look like. So React, Viz, and Recharts were the best in this regard. Another thing is the most developer-friendly experience. So I would put that as VX and Nevo because they had the best rating ratio out of the 6. The sort of which are the fastest to load on mobile, that would be VX with Nevo following behind. What is the library which you're likely to encounter the least bugs on, save the most time on? Probably VX because it has the least number of open issues compared to total issues. And what is the best looking graphing library? Well, that would be Nevo. So if you don't have a designer, I would really recommend that one. Cool, and some honorable mentions as well. So when I came up with, so I'll just briefly gloss over this. When I started researching on this, I wrote up an article and published it to Reddit, and I got some useful feedback on some libraries that people also recommended for specific use cases. So Apex Charts was pretty good for handling if you have a lot of data. And Plotly.js was also quite highly regarded, as well as React time series charts, if you're specifically looking just for line charts. So that's it. My conclusion is 2 important takeaways. Basically, really think about how this decision fits into your project, and think about what you're looking for, and use these metrics to try and find out how to help with those big decisions as well as the small decisions that you may face on a weekly basis as a developer. So yeah, that's it. Any questions?
Thank you very much, Thomas. Any questions?
Hi, thanks for the talk. The tools you showed were pretty awesome. I'm curious if you know any that show you the star history or some media coverage for a particular library that would help you make a decision. Because it can be that some library is very popular, it's got like 10,000 stars, but all of them are coming from 2015.
Yeah, okay. No, I'm not sure if there's a way to see the number of stars over time. There might be. If you do find it, give me a shout.
Any other questions? I think we have one at the here.
What library did you choose in the end, and do you think you made the right decision? Did it work?
Yes, so I went with React Viz in the end because it was the most flexible, and the tool that we were developing was likely to have a lot of very specific graphs and very specific functionality that we needed it to do. Like, for example, hooking up 2 or 3 types of graph together so they're synchronous. The library was built in such a regard that you can, even though it may not come with these features right off the bat, you can very easily add them in and make them work. Yeah. Any more questions?
Cool. Thank you very much, Thomas.
Cool, and just...
Okay, so we're going to take a 10-minute break now, so please feel free to grab another drink, grab a slice of
just 1
pizza.
second.
We're going to be kicking off.
If you...
Sorry, 1 second, please.
if you want a reference of what I talked about in these slides, you can check out our blog. You'll find the article down the list, and it will talk about what I mentioned in these slides. Yeah.
Cool. As I said, 10-minute break. Grab yourself a drink, grab yourself a slice of pizza. We also have some Red Badger stickers and some other goodies free for you to take if you wish to do so. And we'll kick off our last talk at 8:10. Thank you. Great. So, if you'd like to put your hands together for Daniel, please. Thank you.
Hello and thank you. Can everybody hear me all right? Yeah, okay, I can even hear myself, which is great. This is going to be helpful. Hello, this is the final and third talk today, and it's a real pleasure to have a large audience to talk to about React. It always amazes me that so many of us take time out of our busy drinking schedules midweek to listen to somebody else talk about React, which is what they hopefully do all day at work. So thank you for going the extra mile. I hope I'll make it worthwhile. You guys certainly do. So all of these talks are very much about, as React developers, we want to write good React. And we want to understand what is good React towards that end. And originally this talk was very much about, I'm just going to give you some patterns and some techniques to refactor to these patterns. And it was a lot of fun writing, but not a lot of fun actually presenting. So I really asked a more basic question of what is good about React? So I don't know about you, but I joined the React game quite late, about 2 years ago. And it really struck me as a framework that is much more pleasant to work in than any other front-end framework that I've worked in before. For example, Angular. I did not enjoy as much as React. And I really started to get curious as to why that is. What makes React so good, and why does it seem so much better to develop in? Who agrees with me on that, by the way? Is that just me? It is just me. Well, okay, 2 people. Cool. Okay. Wow, why are you here tonight? Okay, I'll do my best to convince you that it's a great framework. And in order to understand why React is good, I think we really need to develop a common language of what React actually is. I know this is a bit late in the day. The third talk on React is finally covering the topic of what React actually is. You've already been waiting for this. Here it comes. Oh, I forgot the pitch. I'm Daniel. I work at Red Badger. I recently joined them. They are a wonderful company. They are great to work with. They have a beautiful office just off Old Street, and they are recruiting people such as your fine selves right now. Speak to the recruitment team. The attractive people at the back of the row over there, give a shout out. They are great. Okay, back to React. What is React? I come from a pretty traditional server-side rendering background, and I used MVC frameworks. And the first time I saw React, I was like, oh, it's just a really good templating syntax. It's like the new handlebar, it's the new mustache. And I wrote code like this, which is valid React, but I think it misses the point a little bit. What you will notice is that it assumes that there's a pre-populated data object that already knows what it's going to render, and it just supplies the HTML for it. So I learned, no. It is a templating syntax still, but it has a modularization feature, so you can compose your HTML modules. And I wrote React like this, which is very, very simple. Does anybody like my to-do app? Pun. I've been working on this very hard. I'd be very disappointed if you don't like it. But this is still not good React, because we have a data object and we just pass it on bit by bit, and it doesn't really express what is in the data, right? Really, React starts being React when you have code that interprets and mutates the data objects and holds state, which led me to realize that React is not so much about building front ends at all as it is a state machine for front ends that has tacked onto it a UI rendering framework and a beautiful syntax for that. Let me tell you what I mean by this. So if you have a well-written React component, obviously you will have things like hooks that define state. You will have callbacks that mutate the state. And then you have child components that you pass properties into based on that state that consume and display it. And this is very much an observable pattern, where the parent components are the observables and the child components are the subscribers and potentially also observables themselves. Which in addition render UI. And the interesting thing about this is that data transformations make the individual components quite agnostic as to where the data actually comes from. So overall, it's a state machine plus UI. It's not a UI plus state machine. I should say at this point that this talk is very opinionated, and I don't have the time to fully justify all my opinions, so if you disagree, there will be a QA at the end of this, and I'm looking forward to your challenges. So now that we know what React is, why is what it is a good thing? So the thing that struck me most about the way code is structured in React, first approaching it, is that the concern of application state and the concern of presenting that state is kind of intermixed, and they are in these little units called components. And people called that encapsulation and said that this is a really good thing because all the code that you need to look at in order to understand a given piece of functionality is in one place. And I thought this was awful because I come very much, as I said, from an MVC background where you have your model concern, you have your controller concern, you have your view concern, and you have your persistence concern, and you may have your AJAX concern, I don't know. And clean code means separating all of these concerns and then having a very dumb templating engine on top of that to visualize all of this. This was spitting in the face of this idea. And it took me a while to realize why, despite my upbringing in MVC, I kind of liked this. I think what it is that when you look at the code that actually renders the visual components, it takes the UI and it transforms it into a visual map of the logical structure of your data model. It very tightly couples the hierarchy and the cascade of your data observables and subscribers and the hierarchy of the visual components in your UI. So in order to understand what your data model looks like, you just need to look at a screenshot of your UI. I haven't really found a good name for this, so I made up a name. I called it co-location. Please come up with a better name for me, and I will update the slides accordingly. But I really, really liked this, because coming to a new project, I don't have to think very much about where I need to look for the code that I need to modify in order to add new functionality, because the UI shows me where it will be. That seems quite trite if you're very familiar with the UI, but approaching a new project, it can be very, very powerful indeed. The other thing that React, I think, borrows from HTML and XML, everybody loves XML, right? Yeah, everybody loves XML, I can tell. I'm reading the room right. But the one good thing is that that the parent elements don't really have a very intimate knowledge of how many child elements it has, how they are structured, what order they appear in. All of this is really left to complete randomness. And that creates a great amount of simplicity and also a great amount of flexibility for parent elements. For example, here this obscenely trivial layout component doesn't know what the layout looks like. It is essentially just a wrapper. And this idea of composition is something that the syntax that React gives you it doesn't really mandate it, but it strongly encourages it. Your code looks nice when you choose composition as a design pattern. And that is, I think, very powerful about JSX in particular. Children, on the other hand, also don't really have to know where exactly they are being rendered. They don't have to know about any global state. They don't have to know who their parents are and who their ancestors are. And this is a concept that I think is called isolation, but I couldn't really find a coherent nomenclature for this. But essentially the idea is that this span that I'm showing here, you can put anywhere. You can put it as a part of a heading somewhere. You can put it in a sidebar widget. This thing obviously doesn't care. And you might at some point say, well, obviously, because this is HTML and this is how HTML works. But remember, it's a state engine. It just has HTML tacked on top of it. It kind of tricks you into writing HTML-like state code. And that's cool. So this is my reminder that this talk is incredibly opinionated. My opinion is, but it's founded in fact and it's the absolute truth as well, that the thing that is really good about React are these four properties. It encourages very good encapsulation. All your code is in the same place. It encourages co-location. Your UI and your state machine have the same structure. It encourages composition, which means that your containers are very flexible, and encourages isolation, which encourages reuse of your individual components. And I submit to you today that if you want to write good React code, a very good guideline on this is going to be a review of how much you care about any of these 4 points and how much you want to reinforce them in your chosen solution. I want to give you a couple of examples of code that I don't like and code that I like. And you have to guess whether I like it or not, based on your understanding that I like these 4 things. You see here a little element. It's just visual. It renders a little error message of, oh, your form submission hasn't worked. Please try again. And it looks like this. Can I have a show of hands of whether you think this code is great? Raise your hand if this code is great. Yes, you've learned so much. Well, some of you have. My problem with this code is that it does not really leverage composition very much. See, this arrow banner has the opinion that it knows exactly who its children are. At some point it will render a title somewhere, then it will render a message and an action for you to try again. It is entirely coupled to its contents. An example that would be more composable would be something like this, where you have the arrow banner as sort of a wrapper, but then the remaining presentational concerns come in as units that you show. It is more verbose, and it is probably not going to be universally more valuable immediately. But what you can do, for example, here is quite easily say, well, what if I can't retry? You just omit this node, right? You just omit the action component. What if I want to have 2 paragraphs in my message? I just have another message element. So it is more versatile in that way. Here's another example of code that I personally don't like. Who likes this code? Okay, no one. Great. So what I don't like about this is this component can only be rendered in one place in your DOM tree. It can only be rendered once. Because it renders a body, there can only be one body, and it renders a head element. There can only be one head. And to make matters worse, it has this unreacty global JavaScript fragment at the top of it that lives outside of any React component lifecycle. So you can really only import this once, and you can really only use it once. So it breaks the principle of isolation. It knows where it lives in the app. And if you break that assumption, the app breaks. Here's a slightly verbose example of how you might make this more isolated. So you use an effect in order to change the window data layer state when the component gets mounted and when it unmounts. You use the helmet library to add a script tag to your head. And you have a main component that isn't the body, but it is just a div like any other. It has the role main. So in theory, you could render this page twice in your page and it would continue to work. You probably don't want to because it's a big accessibility no-no to have two main components. But for example, if you wanted to render a test page with multiple pages, this is now possible. The main point is this component satisfies a high level of isolation. It doesn't know and doesn't care where in the app it exists. But now we get into the interesting part of the talk, if you're a little bit bored, which is the idea of encapsulation and collocation. It's all well and good if you have a static piece of data that you want to render. But what if you have an application that has like a sidebar and a main panel, and obviously it's a to-do app because what other coding examples are there out there? You have a little widget that wants to add that allows you to add a to-do to your to-do list. So you have one component at the very bottom of your structure that wants to impact other components in that structure. And there is an entire history of solutions to that, and none of them are very, very good. And I'm going to give you a little spoiler to the end of the talk. I don't think there is a perfect solution, but there is a solution that I like the most, and I want to share that opinion with you, because that's what I do. So, but the first and original solution that is in the React documentation is obviously, well, you need to send a callback back to the next level so that the next level can re-inject the new data into the other component. But you have to do this not only on one level, but you also have to reach the to-do count component. So you have to lift the state up for a second time into the application. Now the application knows everything about your application. And moreover, the main panel and the sidebar, who are just layout concerns, suddenly know about the to-do-ness of your app as well, right? Because they have to expect that the application passes in to-do data and then pushes more to-do data down to its properties, so to its child components. So the lifting state up pattern has the problem, in my opinion, that it violates encapsulation and composition. Now, this is not new to you. I'm just trying to establish essentially a language. I'm trying to tie back to these four principles that I really like about React and try to make sense, my intuition of what is good React and what is bad React in the kind of context of these four ideas. Okay, so lifting state up adds a lot of complexity and a lot of plumbing to your code. So a alternative solution evolved which said, well, really all that has to change are these three things. So in order to protect the kind of higher order concerns, why don't we have the add to do callback go to some external place, an external data store, and the external data store can push changes into the to-do count and the to-do list. So it looks a little bit like that. And there are many patterns for this. The most prominent one, I guess, is the Flux pattern, which is implemented in the Redux library. There are other libraries as well, like MobX, and there is a quite nice library called Gatsby, which says, well, we have a data store, but we abstract it all the way into a GraphQL interface so that you don't even have to worry about whether it's on the server or whether it's local store. So the idea of having an external data store that lives quite outside your application structure. But I think the reason why I really struggle to work effectively in projects like this is because while it restores encapsulation and reduces the number of things that you have to look at in order to understand what's going on with your to-do app, it does destroy the idea of co-location. Now, your application is no longer a map of where your data lives. It lives somewhere else. Essentially, what you've created is two monoliths. You have a root node of your UI and you have a root node of your data store, and you have to keep them both in your head at the same time. Maybe your project will keep them perfectly in sync, or maybe they will completely drift, but it will be a manual reconciliation process every time. And also on a more subtle point, I think it also, when I say that it retains encapsulation, especially with Redux, one problem that comes up is that your data store, because it is a monolith, tends to get very complex over time. So you need to be quite disciplined in your development projects to keep it clean code. Right. And to the isolation point, the reason why this violates isolation is that there is now a global thing that all of your relevant components need to know about. So if you wanted to have like an app that reuses this entire application in 2 lots, you would have trouble because you would have to duplicate the data store. And because it's not encapsulated into anything that is within the scope of your application, you will probably run into bugs. So one fix to this is to make this data store part of your overall UI structure. That fixes the collocation problem because your UI once again starts resembling your data structures. And it also fixes the isolation problem, as I will show in a second. It would look like this. So you would have a data store underneath your application. And rather than going up and down the UI tree, it talks to this data store directly. But the advantage here is that, as I say, collocation is restored. You don't have 2 monoliths, you have 1 monolith, which is better. And crucially, at least in my opinion, you have this idea that this data store is now owned by that diagram of UI. So you can have 3 of these next to each other, and this restores isolation. This can be quite powerful when you want to componentize and generalize your functionality. So how am I for time? How much time do I have left? Okay, I'm good. Good. So the interface that I'm talking about, of course, is context. The context is a React concept that has been in unofficial support for quite some time. With the release of React 16.8, the code that you need to use this pattern has become much nicer. So it looks like this. Essentially, you create, first of all, a context object. So this looks like it's another monolith, but actually it's just a name. Like think of it as a class rather than as an object. So you have this new type of context, which you can call to-do context. And at some point in your UI hierarchy, you render a provider of the values, which are just normal React state. And then you don't have to do anything else. All you then have to do is to take the components that want to consume that context and use the use context hook. And there are your to-dos. Your layout concerns are isolated from this. It is a very little code. Encapsulation, in my opinion, even though it's in 2 places rather than 1 place, is much improved over a monolithic store. And of course, collocation, which I love so very dearly, is also restored. It is also quite performative in that only components that use the use context instruction, the use context hook, will re-render. All the other child components, things that have nothing to do with your to-do functionality of your app, stay as they are. And finally, and this is really why, this is the moment where, for me, context won over other existing patterns, such as Redux. You can actually compose contexts. Say you have an app that has at one point a to-do context and another point a timesheet context. You can just invoke both of them in your components, and you can have something that takes one of your to-dos and puts it in your timesheet. This keeps the context objects themselves very simple and very small, meaning that they can follow a single responsibility principle. I find that cool. One thing that you can choose is whether you want for your context to manage exactly the shape that your data wants to be in, or whether you want to leave this to your components. My experience for my own work has been that I like to keep data transformations very close to their immediate usage, but the framework leaves it open to you to, for example, build a reducer pattern where you dispatch actions and the state reconciles itself. So if you are very happy with that sort of aspect of Redux and the flux pattern, you can still do this with contexts. It's just more decoupled. Quick note about performance. I've already spoiled this a little bit. One of the problems with context is obviously your context providers are going to be quite top level in your application, right? And one concern is going to be, will this re-render my entire app every single time I change anything in the context? This we want to avoid. And the second concern is, well, maybe my individual component is only interested in a subset of the context. So the best example that I can come up with is, say you build a form, a web form, and you want to keep all your field values in a form context. If you update a single field, surely you don't want to re-render all the other controls. So you want to have some sense of control over whether something that uses a context actually needs to re-render, a kind of should component update type thing. So taking this in turn, I have so this is an unfair question, but if somebody gets this right, I'm gonna get you a beer from back there. So there's a performance issue in this code. Does somebody know? Oh, yeah? No?
It's always a new object.
Yeah, exactly. So it will always re-render the entire application. But do you know why?
Well, because the thing you pass to value is always reallocated when this one is rendered, right?
Yeah, that's exactly right. That's exactly right. But there is a really counterintuitive solution to this, and I'm not sure I can convey the reason why it works within the confines of the time that's left, but I'm just going to show you the answer if that's okay. If you rewrite this app component into two components, one where, so the first one is very, very similar, only that you now have a special to-do provider, which doesn't take any properties. And the way this is implemented is just the remaining code of your app. So something that holds the state and then renders the actual context.provider. It has some magical logic that checks whether the reference on the child element remains the same, regardless of whether the children change. If the reference remains the same, this will not re-render the children. And what this means is that because you have a component that just takes a anonymous children node that is defined somewhere else, and the state is defined in here, you have this desired effect that only the components that use this context get re-rendered. It's a bit of a mind twist. And I'm not entirely sure I understand it myself, but I tested it and it is definitely true. So to illustrate, this is what happens. These things that shouldn't update don't update, and these things that should update because they call use context do update if you use this pattern. So the rule of thumb is the component that defines what the children actually are cannot also be the component that renders the actual context.provider and maintains the provider state. The other performance issue, the slightly smaller one of wanting to filter, is an unsolved problem. So even though this code really doesn't need to know every single time your collection of to-do updates, for example, if you rename a to-do, this stays exactly the same and it shouldn't re-render. But as it is written right now, it does, because the rule is, if you use context, it will re-render. However, the good news is that hidden in the source of React, there is a experimental feature that says that use context has a second property, a second parameter, sorry. And this second parameter is a bitmap. And it is effective when you create your context, which also has a second hidden parameter, it essentially creates a bitmap of all your changed states. So it's sort of like a hash map of the comparison object. And it uses this to compare, it essentially does a bitwise AND. And you can use this methodology to filter the aspects of the context that you want to trigger an update. The name of this parameter is unstable _ something. So do not use it in your production code because the signature will change and your app will break. But it is really encouraging to see that Facebook seems to be on top of these performance issues. So React is definitely heading that way of being able to take a complex context object and decompose it into smaller bits. Okay. I have warned you that it was quite opinionated, and I've spent a lot of time talking about my opinions. But I think it's quite useful to essentially have a shared language of concepts that we can care about and that we can talk about. I submit to you these 4 concepts as a kind of language of saying, Daniel, you're completely full of shit, isolation doesn't matter. And this is exactly the kind of question that I'm looking forward to in the Q&A bit. So thank you very much for indulging me. It's been a lot of fun talking to you. Talk to the Red Badger recruiters. And thank you so much for your time.
Thank you very much, Daniel. Do we have any questions to round off the evening? Got one here.
Oh, here we go. I asked you a really difficult question early in your talk, and now your revenge is coming.
No, I think you've done a really good job. I actually agree with the majority of your opinions. I think they're really quite good, actually. Might try and bring some of that back into the team. Now, I guess my question is, so we are, like a lot of probably people here, using Redux for state management. Mm-hmm. And I couldn't help but think your utilization of use context and the context API mirrors Redux somewhat there in your explanation. You've got a global context like component essentially which is being made, which provides at the top level, a bit like a Redux store, say. And then your what would normally be presentational dumb components down at the bottom are then having to have knowledge of this context, a very specific knowledge of the exact context, and then specific knowledge of the exact methods and attributes of that context, and then are using them at that bottom level, sort of taking away from the container presentational level. Yeah. And it exactly mirrors Redux in the same way that maybe our presentational components would know to dispatch a particular action. Yeah. So you, in that way, quite tightly couple your entire application to a single context and a single set of APIs within that context. So I'm just curious how that fits within those 4 principles you've been talking about.
Yeah, that's a really good observation. So you're absolutely right that I've chosen quite artlessly an example where there's a bit of redundancy. My get out of jail free card to your point is I said there is no perfect solution. But I think the main difference for me is really, if we can get through this, is kind of this. So you're right that in my example, I've chosen a thing that sits on the top level and it's the only context object. And in that way, it is a global concern. There is going to be a quite tight coupling at the very least between the things that consume the context and the actual shape of the context, and therefore the provider. That's why, cleverly, I set encapsulation asterisk. So I think the value gain that I see over not so much the flux pattern, but certainly the redux pattern is that context doesn't assume that there's only one context, and it doesn't assume that all the contexts that you may have access to in a given place in your UI hierarchy exist at the same level. So for example, you might have a top-level thing that sits on top of the page that controls whether you're authenticated or not, right? And then lower down, you can render a form, and that gives you a form context that gives you the values of your fields. And it's this compositional aspect and the isolated aspect that you can reuse these units because they are part of your overall structure that I find very intuitive and rewarding about the context pattern.
Any other questions?
Yeah, this is kind of about components in any context, but I was just wondering about CSS, if you have any thoughts on cascading style sheets and their ability to cascade as like an enemy of isolation.
I have so many opinions about CSS, and they are the most controversial opinions that I have in the technical space. So let's park this and find me after this. I'll tell you all about my CSS opinions.
We've got time for one more.
Yeah, I just, when I'm looking at the way React handles state, something that I really would like to be able to do is pass in a data context that a component could then update as well as read, which is a bit getting into the two-way binding world, but that would seem to, if maybe something like, if it was possible for a context, the React context that we already have, to be decomposed in some way and then passed into child components, something like that strikes me as being even better. I don't know what you think.
Yeah, so please correct me if I don't fully understand your question, but I think what you're alluding to is this idea of, for example, when you, oh no, I can't find it, crap. Oh yeah, so when you have state of any shape, obviously you have a read concern and a write concern, right? And here in this example, I'm putting this as a complex object. Here's all your values, and here's a means to update those. I think, in my opinion, the context pattern is for this really quite good, because what you do is you run an update. You set the state, but you're also subscribed to the result of your update. So you will immediately interrupt your render and re-render with the new values. There are some intricacies of, there is potential for bugs that cause an additional re-render, and you have to be a bit mindful of that. But when done right, it can be quite a good solution to what I think you've described.
Great. Thank you very much, Daniel.
Thank you.
Okay, I just want to say a few things before we wrap up. So first thing, I just want to say a big thank you to all of our speakers and also ASOS for letting us host the event here. So, as Daniel said, we are hiring a bunch of developers at the moment. So you are interested in joining our team potentially. You can head on over to redbadger.com/jobs to find out the jobs we're exactly looking for and some of the specs and some of the tech that we're using as well. We'll also have some postcards at the back, which just give you a little bit more information about Red Badger as a company and what we do and how we do things. So feel free to grab one of those. I'm not actually sure there's too many left, but grab one if you want to. So there's a pub down the road, not far, just as you come out of the building, just on the left. It's called the Littleton Arms. So if you feel like having a few more drinks, maybe making a night out of it, you can go over there, do some socializing. I think we'll all be there as well if you want to have a chat, all things Red Badger, or obviously any other questions about the talks. Finally, I just want to say a big thank you to you. The meetup wouldn't be what it is if you guys didn't turn up. So big thank you to you, and I look forward to seeing you at another meetup. Thank you.